Hello and welcome to a brand new video. So before we go any further, please note the warning, I guess it is, at the top. So you do need to complete lesson 25B before you complete this lesson, because in this lesson, we use things that we figured out in 25B. So in order for you to have that resource, you need to complete it before you complete this lesson. So this is your warning. If you haven't done 25B, stop, go back and finish it or do it, and then come back to this video. So moving forward, we are continuing talking about trigonometry. So trigonometry, I don't think I've actually said it. It's when we're studying triangles and wonderfulness that is opposite, adjacent, and hypotenuse. So we're on this problem right here. So the reason that we needed to do 25B before we completed 25C, other than alphabetical shenanigans, is because the angles given in these next three examples are not two of them are not common angle measurements that you're going to see a chart for. So we're going to use the proportions and sides given that we figured out in the last assignment, and we're going to apply that knowledge to these triangles right here. So we're going to start off by identifying what we know. So we know that we're given this angle right here, angle 53. That's 53 degrees. And we're also given this side. So the side we're given is the hypotenuse. So we can fill in our hypotenuse right away. It's 7. We're given that information, we can fill it in. So now what we need to do is we need to set up a proportion using the information that we already know. So in order to find out what we need to go back to our chart, the chart we made yesterday. Or the previous lesson, it might not be yesterday. But using that this angle is 53, we're going to be looking at triangle DEF. So in triangle DEF, we know that our opposite over hypotenuse, I'm switching to the dot cam. So the opposite over hypotenuse was 4 over 5, which equals 0.8. So that means that in our new triangle, it's going to be opposites over 7 equals 0.8. Because they're both going to equal the same function. They're going to equal the same number because they're similar triangles, okay? So they're going to equal same because similar triangles. And we know they're similar triangles because they're both right triangles and they share an angle measurement. So now what we're going to do is we're going to solve for this. So what that means is we're going to get the opposite by itself. So in order to do that, we're going to multiply 7 and 0.8. So we're going to do 7 times 0.8, and we get 5.6. So that means our opposite side length is 5.6. So we're going to come back over here, and our opposite is going to be 5.6, and we're just going to fill it in like that. So now we're going to do the exact same thing for adjacent. So it might be, I should have said this like 3 seconds ago, but it might be helpful to have 25B open while you're doing this. That way you can flip back and forth between 25B and 25C. I have my notes in front of me in case you're wondering why I'm not flipping back and forth. So we're going to go back over to the dot cam so we can solve for adjacent. Okay, we're going to solve for adjacent. So for adjacent, we are going to be using, let's make sure I have this right. We're going to be using the 3 over 5 equals 0.6. So this is what we're going to make it equal. So we know it's going to be something over 7 because we know that our hypotenuse is 7. Whoops, that should be adjacent. So it's going to be adjacent over 7 equals 0.6. So now we're going to do 7 times 0.6. So 7 times 0.6, and that equals 4.2. So again, we're solving for this missing piece. Okay, so in order to get the adjacent by itself, we multiply both sides by 7 because the opposite of dividing is multiplying. So we're going to come over here and we're going to fill in our adjacent, which is 4.2. Okay, so if you're wondering which is which, adjacent is our x and opposite is our y. Okay, so now we're going to go to our next one. So for this next one, we have the given angle of 30 degrees. We have the given angle of 30 degrees. So we're going to go to our 25B and we're going to look down our angle measures, which is the third column from the left. And we're going to find the angle measurement that matches 30. So in this case, that would be triangle 4JKL, because we know that one of the angles is 30. So now what we're going to do is we're going to look down here. Okay, so we're going to look. So in this case, we are given the side that is opposite of the marked angle. So that means 9.2 is our opposite. Okay, 9.2 is our opposite. So now when we come over to our working space, just going to shift this down. We know that we are going to have 9.2 is our opposite, and it's going to be over our hypotenuse. That's a really bad 9. I apologize. And it's going to equal 0.5 because in the case of our triangle 4 over 8 equals 0.5. So we know they're going to equal the same number. So for this one, we need to get the hypotenuse by itself. But in order to do that, we need to have it not be on the bottom. So the first step to getting it by itself is we're going to multiply both sides by the hypotenuse. So we end up with 9.2 equals 0.5 times the hypotenuse. So now to get the hypotenuse by itself, we're going to divide by 0.5. So we're going to do 9.2 divided by 0.5. And we get 18.4. So that means our hypotenuse is 18.4. So now that we know our hypotenuse, we can apply that to our adjacent over hypotenuse. So our adjacent over hypotenuse is going to equal 0.87. So that means it's going to be something, or adjacent, over 18.4 equals 0.87. So again, we're using our knowledge from the last lesson and the numbers we already figured out, because we know that if they're similar, when we divide them out, when we divide the adjacent by hypotenuse or opposite by hypotenuse, they're going to equal the same number. They're going to equal the same number. So we're going to do 18.4 times 0.87. 0.87, so we can get the adjacent by itself. And when we get the adjacent by itself, we get 16.008, which in this case, even if we rounded to 2 decimal places, that would be 16.01. And at that point, we might as well just write 16. So going back and filling in our Google Doc, our adjacent is equal to 16, and our hypotenuse is equal to 18.4. Okay? So now, going on to the next one. So for the next one, we see that our marked acute angle is 67. So then we're going to come back over to 25B. And the angle measurement that matches the 67 is triangle ABC, that first example. So now we're going to apply our knowledge of that first example to what we're given. So in this case, we were given, I did not mean to click that. Oh well. We were given the side that is opposite of the acute angle. So we are given that the opposite equals 21.6. The opposite equals 21.6. So now what we need to do is we need to find our adjacent and our hypotenuse. So we're going to come back over to our DocCam. We're going to set up our proportions. So for triangle A, B, and C, we have our opposites, which equals 21.6 over our hypotenuse. We know it's going to equal the same number as when we figured out that triangle ABC. So in our chart, it says that 12 divided by 13 equals 0.92. So that means that this is going to equal 0.92. So now we need to get the hypotenuse by itself. So we're going to multiply both sides by the hypotenuse. So we get 21.6 equals 0.92 hypotenuse. And then divide both sides by 0.92. So we have 21.6 divided by 0.92, and we get 23.48. 23.48. It's actually 23.4782609, but since we're rounding to 2 decimal places, we're rounding it to 23.48. So this is how long our hypotenuse is. So now we're going to apply our knowledge of what our hypotenuse is, and we're going to find our adjacent. And so from our chart that we figured out in the last lesson, we know that our adjacent over hypotenuse is going to equal 0.38. So now we need to get the adjacent by itself. So in order to do that, we're going to multiply both sides by 23.48. So 23.48 times 0.38 gives us the adjacent equaling 8.92. Because when you multiply it out, you get 8.9224, which rounds 2 decimal places, 8.92. So we're going to come back over and we are going to fill in our sides that we just figured out. Okay. So again, we used our chart that we did in the previous lesson to help us solve these problems, because when you divide them out, they're going to equal the same number if they are similar. Okay, and the reason we know that they're similar, because all of these are right angles or right triangles. So that means 1 degree is always one angle measurement. It's always going to be 90 degrees. And if you know what the other one is, that means that missing angle side is always going to be the same for similar triangles, because definition of a triangle, they always add up to 180. So now, down here, we have a picture. And it says, from a point 120 meters away from a building, Serena measures the angle between the ground and the top of a building and finds it measures 41 degrees. What is the height of the building? Round to the nearest meter. So in this case, we're given the adjacent and we need to find the opposite. So notice how we were given the adjacent and we need to find the opposite. So in order to find the opposite, we are going to have to find the hypotenuse. So let's start by finding our triangle that is similar to this one. So we know that one of the measurements is 90 degrees because it's a right triangle. And we know that another one is 41 degrees. So we're going to come back to our 25B and look for the triangle that has 41 degree angle measure. And I see that triangle GHI has an angle measurement that is 41 degrees. So we're going to use this triangle to help us with this. So we know our adjacent, right? We are given that our adjacent is 120. Does it say meters? It gives us, I didn't know if it gave us units, and it did. So we know it's going to be 120 meters. Okay. Now 120 meters is going to be over hypotenuse. And it's going to equal 0.75. Because what we have to do is, because over on our chart, our adjacent divided by hypotenuse equals 0.75, which means in this case, 120 over our hypotenuse is also going to equal 0.75. So now we need to solve for hypotenuse. So we multiply both sides by our hypotenuse so we can get rid of the fraction. Then let's divide 120 by 0.75, and we get 160. So now we know our hypotenuse is 160, and right now we needed to find our hypotenuse so we could apply it to find our opposite. So now that we know our hypotenuse, we're going to use our opposite over hypotenuse number, which for the triangle whose measurement equals 41, we know it's going to equal 0.66, because that's what opposite over hypotenuse equals in the triangle that is similar to this triangle. So now in order to find the opposite, we're going to do 0.66 times 160. And when we do that, we end up with 105.6, which means, what is the height of the building? Round to the nearest meter. So the opposite equals 105.6, and the height, because we're rounding to the nearest meter, we're going to round to the nearest ones place, right? The nearest whole number. So the height equals 106 meters, because the 6 makes the 5 round up. So our opposite side equals 105.6. Let's write in our hypotenuse. Equals, I know I spelled that wrong, I'm going to fix it. Hypotenuse equals 160, our opposite equals 105.6, and our height equals 106 meters. Okay? So again, this is why having that chart is so vitally important. So now, rather than you flipping between two documents, I have given you a chart. So this chart is going to be helpful because it has going by tens, all of the opposites over hypotenuse and all the adjacent over hypotenuse from 0 to 90. Okay, it goes from 0 to 90. So now what we're going to do is we're going to apply this chart to some word problems. So we have a beautiful problem that's labeled number 6, and I apologize for how wonky some of the numbering is, but if you're not used to it by now, oh well. So number 6, this next problem reads, 3 city streets form a right triangle. Main Street and State Street are perpendicular. Laura Street and State Street intersect at a 50-degree angle. The distance along Laura Street to Main Street is 0.8 miles. If Laura Street is closed between Main Street and State Street for a festival, approximately how far to the nearest 10th will someone have to travel to get around the festival if they only take Main Street and State Street? So, to help us understand what we just read, let's draw a picture. Because sometimes you need a picture in order to understand what's happening. Okay? So, first off, we know that Main Street and State Street are perpendicular. So that means they form a right angle. Okay? So we have Main Street and State Street. Okay? Then it says Laura Street and State Street intersect at a 50-degree angle. So if Laura Street's over here, that means this is 50 degrees. Then it says the distance along Laura Street to Main Street is 0.8 miles. So our diagonal is Laura Street, and this distance is 0.8 miles. So it's saying that Laura Street is closed between Main Street and State Street for a festival. Approximately how far to the nearest 10th will someone have to travel to get around the festival if they only take Main Street and State Street? So in order to find that information, we need to find the lengths of this side and this side, so we can add them up to know how far they need to go around. So let's use this 50-degree angle that we know. So we have our hypotenuse, and that equals 0.8. So now we just need to find our opposite and our adjacent. So 50 degrees. So we're going to come over to our table. Okay, we're going to come over to our table. We're going to locate the 50 degrees, and then we're going to locate the two numbers. So we know that our opposite over hypotenuse is going to equal 0.7660. Okay, so we're given this number. So we know that when we divide our triangle from our problem, the opposite divided by hypotenuse, we know we're going to get this number. And then for adjacent over hypotenuse, we know we're going to get 0.6428. And we know when we divide that out, we're going to get 0.6428. So now that we know, using our chart, what the numbers are going to be when we divide them out, we're going to come back over here and we're going to apply what we know. Okay, so we know our hypotenuse. So let's start with our opposite. So we know it's going to be our opposite over 0.8 equals 0.7660. We know that our opposite divided by this is going to equal this number. So in order to find what our opposite equals, we're going to multiply both sides by 0.08. So in our calculators, we're going to do 0.8 times 0.7660. And when we do that, we get opposite equals 0.6128. For right now, we're just going to leave it as many decimal places and we'll round at the very end. Okay. So now we're going to figure out our adjacent. So for our can't talk this morning. For our next problem, we have our adjacent over our hypotenuse, which we already know, 0.8, and we know it's going to equal 0.6428. 0.6428. So now in order to get adjacent by itself, we're going to multiply both sides by 0.8 so that we can get it so we can get the adjacent by itself on one side of the equal sign. So we have 0.8 times 0.6428. And when we do that, we get 0.51424. So now that we know our opposite equals 0.6128 and our adjacent equals 0.51424, so now that we know what they equal, we need to add them so that we know how far someone has to go to avoid Laura Street between this point and this point. So now we're going to add the two. We're literally going to type in 0.6128 plus 0.51424. And we get 1.12704, which is definitely not 1/10 or one decimal place. So we're going to round to the nearest tenth. Okay, because that's what the question asked us to. So when we're rounding to the nearest tenth, we're looking at this place. We see that if it's greater 5 or greater, we round up. If it's less than 5, we round down. 2 is less than 5, so we round down, which means it's 1.1 miles, correct, to avoid Laura Street. And we're going to write that exact statement over on our document. So we know it's going to be 1.1 miles to avoid Laura Street. Laura Street. Okay, so that's that problem. So for the next one, we are given the 70 degrees. And then they didn't label it on the picture, but they labeled it in the description of the problem. So what we're going to do is I am going to set you up and then I want you to finish the problem on your own. So what I mean by set you up, we're going to make sure we identify which numbers we're using and then label the picture accordingly. So because it's 70 degrees, okay, we're going to be looking at our 70-degree column. Okay, so we're looking at our 70-degree column, which means that our opposite over hypotenuse is going to equal 0.9397. Every triangle that has a 70-degree angle, as the marked angle is going to, the opposite divided by hypotenuse is going to equal 0.9397. And our adjacent over hypotenuse is going to equal 0.3420. 0.3420. Okay, so we know what our two numbers are going to be. So now we have our wonderful picture, 70 degrees. It's the anchor point. Okay, we know that this is a right angle because it's identified in the picture. So it says the cable anchors a utility pole to the ground as shown in the picture. The cable forms an angle of 70 degrees with the ground. The distance from the base of the utility pole to the anchor point is 3.8 meters. So it's asking how long the hypotenuse is. So you are given the adjacent. You need to find the hypotenuse. Okay? So you're given the adjacent and you need to find the hypotenuse, which means that you're not going to need the opposite over hypotenuse for this scenario because you're given the adjacent, you need to find the hypotenuse. So complete this problem on your own and then start working on 25D. Okay, it's problems exactly like the ones we just did. You have to find, you're given either the opposite, adjacent, or hypotenuse, and you need to find the other two missing sides. Okay, if you need help, call or text me as per normal. You can also email me, or you can private comment on your assignments. I try to get back within 10 minutes. Sometimes if my ringer's not on, it might be slightly longer. But I always respond if you comment on your homework and assignments. Sorry, not homework. So that is it for this lesson.